Good morning, teacher. My name is Hoang Thinh. My student ID is s4113609, and today I'm excited to present my submission for assignment 2 of the Cloud Foundation course at RMIT University. In this video, I will demonstrate the full execution of an AWS cloud project for the cafe chain business. Throughout each task, I will discuss the implementation steps and show the relevant academic references. Now, let's begin with task A. First, I will create a VPC and create a new one. Create VPC. I choose VPC only and bypass the VPC and more. The name tag is my SID with VPC, and then the IPv4 is 10.0.0/16, and I keep it all default and create VPC. So after that, I will go into the internet gateway and I will create a new one, internet gateway with my SID, and I create an internet gateway. Then I attach to a VPC. The VPC is my SID VPC, and then I attach internet gateway. The third step is to create 4 subnets. So I put create 4 subnet, create subnet, connect to the VPC with my SID. So then I will create subnet for all the subnets. So after this, all the subnet is created, as you can see here, and then I will configure the root table. I will create a public root table first, public RT, and the VPC with my SID, and create root table. And then in the roots here, I edit the roots and I add new roots for the internet gateway in here. And the internet gateway is with my SID, and I save change. And after that, I will add the subnets. I choose 2 public subnets, public subnet 1 and public subnet 2, and then I save association. After that, I will create one more root table, is private root table, and with the VPC, and then I create it. I will bypass the roots, move to the edit subnet association, and add 2 private subnets in here. So after that, this is the end of task A. To complete task A, I use these reference to help me create VPC, create subnets, and create a root table from AWS document. Now let's move to task B, is creating a static website with EC2. So I will go to EC2 here. The first one, I need to create a security group for this. So I go to security groups and create a new one, which name is WebSG, and description is web security. And the VPC with my SID. Inbound rules here is HTTP, custom from anywhere from IPv4, and the second one is SSH, and the same one with HTTP, and then I create security group. The next thing I create is to launch an instance. So I launch an instance. Its name is static website. Static website. The AMI is Amazon Linux 2023, and its type is T2 micro. The keybase is VOKey, and the network setting, I will click here to edit it, and the subnet 1, public subnet 1, enable it, and choose the security group. This WebSG as I create before, and advanced detail. I will scroll down and I paste this user data, and then I launch the instance. Just wait a minute, and then the instance is created, but you have to wait a few minutes for the instance going to run. So I will to elastic IP to set an elastic IP for it. So I allocate it and allocate. After a new IP address is published, I will click in here, and actions, I will associate with elastic IP. I choose instance with the static website, and then I associate. So after that, I will go back to the instance. It's running, or it's already running, but I need to wait for the static check. After the static check with 2/2 checkpass, I will click here and I copy the public IP address here. I open a new browser, // and then I will paste this. And after the website is launched, so that's the end of task B. With task B, I learned how to use EC2, create the IP address elastic, and run the Slack website using AWS tutorial. Now let's move to task C. I will create a new security group for the database. First, I will go to the security group and then create a new one. Its name is DBSG. The description is a private security group. And the VPC is with my SID. The inbound rules is from the MySQL and Aurora. And the short is from the WebSG. And then I create a security group. Then the DBSG is created. The second step is to create a subnet group for RDS. So I will go to Aurora and RDS. I go to the subnet groups, create a DB subnet group in here. So I will create my DB subnet group. Description is a private subnet group. And the VPC with my SID before. And then I will add two subnet is one A and one B. And the subnet is two private subnet. And after that, I will create it. The next thing I create is creating a database. So I will go to this and I use MySQL. I will choose sandbox with single AZ. And in here, I will choose the MySQL with 5. The version is 5.7. And the instant identifier is dynamic DB. The master username is admin. The master password is admin12345. Admin45. And connectivity in here, I will choose my SID. And the VPC, I will deselect default and choose the DBSG. The additional configuration, I will name it inventory. And then I will create a database. After the database is available, I will click here. And then I choose endpoint to copy the endpoint. And I will pass it into the notepad. The next thing I need to create is create a new instance for the dynamic website. And here I will launch instance. Name is dynamic website. And its AMI is very important. I will click on marketplace, search for Amazon Linux 2. I will choose the first one, lunch, supply and lunch. In this instant type, so this is my AMI information, and instant type I will to T3 micro because T2 micro is not supported. The keybase is VOKey. Network is with my SID VPC. The subnet mask is public subnet 2. Auto design public IP, and selecting existing security group is the WebSG. And for the advanced detail is important. AMI instant profile, it must be the lab instant profile. And scroll down, I will copy the user data from the document and in here, and then I will launch instant, view all instant, and in here I will wait for the dynamic is ready to access. Now the dynamic website is ready to access. I will copy the public IP So as you can see here, the inventory system, and I will click setting, and I will paste the endpoint of the dynamic DB. The name is inventory, the username is admin, and the password is admin. So as you can see here, the table is ready. After the table is ready, I will add, if it can add a new inventory store, I will click hello in here. The item, I will click computer, and the quantity I will choose to 6, and I will submit. So as you can see here, a new item has store item and quantities is added into the table. For task D, this reference is Amazon RDS, create the EC2 IAM roles and RMIT lecture.with9 database. Moving on to the task D, the requirements was to set up S3 buckets for archiving and social media photos. So then I click to create a bucket. And for the global namespace, it must be unique. So I decide to choose my SND first, and then the website archive 2026, and give everything default, and then I will create a bucket. So just a minute. So the first bucket is created, and then I get back to the console, the Amazon console, and then I create a second one. The second one is for the storing the social media photo. So as again, I choose s4113609, and then social media photos. Photos, and keep everything simple. And then I create buckets. So as you can see here, Amazon S3. So as you can see here, 2 buckets is created now. So that's the end of task D. With task D, I only use one reference to create S3 buckets. Hello teachers and friends, today I'm happy to present my system architecture diagram for our cloud computing project. I will explain the main engineering steps and the overall flow of our AWS setup. We deploy the infrastructure in the North Virginia region. The whole system is safely placed inside a VPC to make our application is highly available. We divided the network into 2 availability zones, Zone A and Zone B. This means if one zone goes down, the system can still run. Let's look at how users interact with the system. Users connect through the internet gateway. It's important to note that this is a two-way connection. The internet gateway receives the request from the user, and the system also sends the data and the feedback backwards directly to the user through this exact same path. Now, next, we move to the public subnets. This is where our subnet web servers live. In Zone A, we have an Amazon EC2 server with an elastic IP address. This server runs our static website. We use a user data script to automatically install and start the website when the server puts up. In Zone B, we have a second EC2 instance. This T2 micro instance is run our dynamic application, which we call the inventory app. Both these servers are protected by the security group. It acts like a digital wall. It only allows the safe web traffic like HTTP or secure SSH connections for administrator. Now let's talk about the database. The inventory app connects to the Amazon RDS MySQL database. For maximum security, we put this database inside a private subnet in Zone A. No one on the public internet can reach it. Also, to focus heavily on AWS cost optimization, we clearly decide not to use an NAT gateway. The database simply talks to the EC2s inside the local network. Finally, on the right side, we use Amazon S3 for file storing. S3 is outside the VPC. We create 2 separate buckets. The first bucket is archiving our old website data. The second bucket is especially for storing social media photos. Using S3 keeps our main servers running fast and save a lot of money. To conclude, this architecture is secure, high available, and very cost effective. That's the end of my presentation. Thank you very much for listening. For the final requirement, task F, I have prepared a total cost of ownership estimate to our entire project. As instructed, I'm including the AWS pricing calculator summary as a part of this presentation. For the static and dynamic websites, I include 2 T2 micro EC2 instance running Linux with 10 gigabytes of EBS storage. For these, I selected a 3-year compute saving plan with no upfront costs. For dynamic website backend, I add a database Amazon RDS for my SQL instance in a single AZ deployment, utilizing 20 gigabytes of general purpose SSD storage on an on-demand pricing strategy. In the storage factors, I factors in 10 gigabyte per month of Amazon S3 standard storage to cover both the website archiving and the social media photos. Lastly, I include a cost of 2 in-use public IPv4 addresses attached to our instances. Look at the final summary. There's an upfront cost of $0 USD. The calculator estimate a total monthly cost of exactly 72.46 USD, which brings our total 12-month projected to cost to 869 USD. This cost estimate demonstrate that our architecture is financially viable and optimize our cafe change digital launch. This concludes my video presentation for all tasks of Cloud Foundation Assignment 2. Thank you for your time.